Okay guys, so now we're going to look at the chemical properties of your carboxylic acid. So the reactions that your carboxylic acid can undergo are these. Okay, so we'll look at it one by one. So the first one is reaction when your carboxylic acid act as acid. That means that it's going to donate H plus from the OH group. Okay, the first reaction is neutralization reaction. So awak ingat daripada thermochemistry, when you react acid and base, you will get salt and water. Okay, so that means that you're going to remove water. Okay, and you will get salt. Okay, so your acid is carboxylic acid. When it reacts with your base, let's say sodium hydroxide, okay, you will get your carboxylate salt. Okay, maksudnya dia akan release hydrogen, and yang O minus tu akan form ionic bond with Na plus. So that's how you get your carboxylate salt. So salts, that means that you have to show the negative and positive charge. Okay, ni water ni awak remove daripada sini, daripada H of your OH bond and your OH minus daripada base. Okay, next you have the reaction with electropositive metals. So electropositive metals like these, they are from group 1 and group 2 metals. So yang ni you have to know how to balance lah the charges. So let's say you have carboxylic acid reacting with metal M, okay, where this is your group 1 metal, okay. So it will form M plus, and when you release your hydrogen, you will get O minus. So ni awak tunjuk je, okay, how it forms the ionic bond, O minus M plus, and have hydrogen gas as your byproduct. Alright, so ingat je lah carboxylic acid boleh react dengan electropositive metals. Okay. Okay, next you have this type of reaction, a substitution reaction of your OH group. So this will form derivatives. Okay, maksudnya banyak-banyak adik-beradik lah. Kononnya, something like that, macam saudara dia. Okay, so we'll look at the first one, A here. That is acid chloride formation or acyl chloride formation. So these are your acyl chlorides. Ingat kan, C double bond O is acyl and Cl is chloride. So when you react your, macam alcohol, okay, if you react your carboxylic acid with these reagents, okay, you will substitute your OH with the Cl. So you will get acyl chloride, okay, with its respective byproducts. Okay, itu untuk form acyl chloride. Okay. Okay. Next you have you can also form acid anhydride. Okay, apakah acid anhydride? It looks like this, acid anhydride. So the anhydride, okay, acid anhydride ni dia punya identity is this carbonyl oxygen carbonyl. Okay, that's acid anhydride. So there's two ways for you to form acid anhydride with your carboxylic acid. Okay, so you can react your carboxylic acid with acyl chloride in the presence of pyridine. So this is pyridine, okay, and you will get acid anhydride and eliminate HCl. So you will eliminate H from your carboxylic acid and you will eliminate Cl from your acyl chloride. Okay, so that's the first way for you to form acid anhydride. Okay, the other way for you to form acid anhydride is by reacting carboxylic acids with each other. Okay, so it can be the same carboxylic acid, the same exact R group, or it can be different one. So depends what kind of acid anhydride you want to form. So this reaction will take place in the presence of P2O5 will being heated. Okay, beza daripada guna acyl chloride tadi, when you use carboxylic acid, okay, macam formation of ester juga, the byproduct is different. Okay, when you use carboxylic acid reacting with each other, you will remove water. So you will remove H from one of the carboxyl groups and you will remove OH from the other one. Okay, so lepas tu nanti dia akan just sambung je lah. Okay, sambung je. Yang ni pun tadi disambung je. Okay. So ingatlah acid anhydride tu awak ada carbonyl, oksigen, carbonyl. Okay. Okay. So you can form different acid anhydrides. Okay. Contohnya, oh my god. Okay. So contohnya, if you react, ini apa nama dia? Dengan ni. The same carboxylic acids. These are ethanoic acid because you have 2 carbons. So ethanoic acids together. Okay. In the presence of P2O5 will be heated. You will get ethanoic anhydride. Okay. So ini anhydride. Okay. Kita panggil ethanoic. Why? Because you have 2 carbons on this side and 2 carbons on this side. So if it's ethanoic anhydride, that means that you have the same kind of a mirror lah dengan symmetrical molecule. Okay, dia ethanoic on both sides. And then you remove water ni lah yang macam tadi. Let's say if you use different carboxylic acids together. Okay, yang ni ethanoic acid. Ini 1, 2, 3. This is propanoic acid. Okay, you will get 3 different anhydrides. Okay, one of them is ethanoic, denoting this part, 2 carbons. Propanoic, okay, 3 carbons. Anhydride, okay, ethanoic, propanoic, anhydride. And then you also get ethanoic anhydride. Yang ni tak payah cakap ethanoic, okay, because it's the same thing. Anhydride tu faham dia the same number of carbons on both sides. So ethanoic anhydride. And you get propanoic anhydride. And your byproduct is water. So ingatlah, bila awak guna the same carboxylic acids, you will get one type of anhydride je. Okay. Okay, next we have the formation of amide. So what is amide? Okay, amide is formed daripada amine actually. So if you directly use your carboxylic acid to react with ammonia or any of the amine derivatives, primary amine or secondary amine, okay. Ini primary sebab dia ada 1 R group, ini secondary sebab dia ada 2 R group, okay. You will get a secondary amide and tertiary amide respectively. Okay, but using carboxylic acid directly with these ammonia and its derivatives is not so favorable, okay, because your carboxylic acid has low reactivity towards these reagents. So maksudnya dia tak laju lah nak form, dia tak stable sangat nak form, dia tak suka sangat. So how can we make what is the better pathway, the more favorable pathway? It is this pathway below. So instead of using your carboxylic acid directly, you form acyl chloride from your carboxylic acid. So start daripada carboxylic acid. First you change it to acyl chloride by reacting with SOCl2 ke PCl5 ke PCl3 kan. So gantikan OH ni dengan Cl. Okay, dah dapat acyl chloride. And then you can react lah dengan your ammonia dengan amine derivatives. So ini adalah ammonia, NH3. This is amine, primary amine. Okay, because it has 1 R group attached to this end. Ini ada secondary sebab dia 2 R groups. Okay, so if you react your acyl chloride with ammonia, you will get primary amide. Okay, dia bukannya ini primary amine dapat primary amide Ini adalah acyl chloride react with ammonia, you will get primary amide. Okay, so primary amide ni macam mana classification dia? Dia beza daripada amine atau classifying yang lain. Okay, instead of tengok number of carbons, we are going to look at the number of hydrogen attached to it. So if you have NH2, this is a primary amide. Okay, I'll tengok number of hydrogens. NH2 primary amide. Okay, so basically apa yang berlaku is that you have ni ethyl chloride. Okay, C double bond O, Cl. So this R group akan simpan here. Okay, tapi ini one of the hydrogen will react with this Cl and then will form HCl. So ini tinggal 2 hydrogen. So dia jadi NH2. Ini actually I think I will check balik. I think I'm wrong. Ini patutnya HCl ni rasanya. Okay, so secondary amide pula, you have 1 hydrogen attached to this nitrogen. Okay, dia NH saja. Tertiary amide, N tak ada hydrogen langsung. Okay, no hydrogens attached. That means it's a tertiary amide. Okay, so ingatlah when you react your carboxylic acid buat jadi ethyl chloride and then react with these derivatives. Kalau primary amine, you will get secondary amide. Okay, secondary amine, you will get tertiary amide. Alright, so that's that. One more thing here is esterification. I think you are familiar with it. When you react your acid with alcohol, okay, in the presence of a strong acid like H2SO4 while being heated, okay, you will do elimination reaction where you will eliminate water. So then you will get ester. Okay, ester. So maksudnya this R group, this OR comes from your alcohol lah. Okay, and you will eliminate water. Okay. Okay, finally we have reduction reaction. Okay, so reduction reaction with lithium aluminium hydride to form primary alcohol. Okay, so when you your carboxylic acid undergoes reduction with this followed by hydrolysis, you will form primary alcohol. I think ini dah belajar lah dalam preparation of alcohol. Okay. Okay. Finally, lastly, betul-betul last. Okay. Ini penting sebab I saw this question come out for PSPM like twice or thrice in past years. So it is the concept of methanoic acid acting as a reducing agent. Okay, so apa yang special pasal methanoic acid ni? So methanoic acid, that means that the acid ada carboxyl group. Okay, and it has 1 carbon. So dia adalah methanoic acid. Meth maksudnya 1 carbon kan. So this methanoic acid, it has both the carboxylic acid functional group dengan carbonyl functional group. Okay, here this is your carbonyl, and on this part you have your tadi ni carboxyl, and this part you have your aldehyde class. Okay, your carbonyl group. So this because it has methanoic acid ni, it has an aldehyde group, so it can act as a reducing agent. So that means that methanoic acid can undergo oxidation lah. Okay, dia boleh undergo oxidation since dia adalah reducing agent. So dia akan reduce apa dalam oxidation reaction tu? Kita boleh exhibit that property by oxidizing your methanoic acid lah using KMnO4 in the presence of acidified water, okay, or K2Cr2O7, or you use Tollens reagent. Okay, so maksudnya this will be oxidized, okay, into CO2 while, okay, your KMnO4 ni here, okay, so at first dia ada oxidation state of 7. Kalau ini 5, 6, 7. Okay. After it undergo reduction, kan? Because methanoic acid undergo oxidation, dia ni undergo reduction, the oxidation state will decrease. So sekarang awak ada Mn2+, daripada plus 7 jadi plus 2. Okay. So ini menunjukkan the reducing properties, okay, when your methanoic acid act as reducing agent lah. Same case here. your methanoic acid will reduce your AgNH3 2+, your tolerance reagent. Daripada Ag tu dia ada +1 oxidation state, dia jadi Ag0. Maksudnya oxidation state dia 0. Okay. So this is explained because your methanoic acid has an aldehyde group dengan carboxyl group. Okay. The aldehyde group tu yang allow it to act as reducing agent. Alright. Okay, that's all for carboxylic acid. So nanti boleh buat tutorial, okay? Bye.